Well, hello people. Welcome to your homework feedback video for the CGP Whitebook, pages 198 to page 203. Same rule as always. Please get your green pen. Please give yourself a mark if you got it right. Please write down the correct answer in green if you got it wrong. Let's start in less than 15 minutes. I'll attack. Reducing unwanted energy transfer. So remember, energy can be transferred from one store to another. Energy is wasted when it's transferred to a less useful store. So, figure 1 shows a thermal image of a house. Different parts of the outside of the house are at different temperatures. The owner wants to keep the inside of the house as warm as possible. Suggest where the highest rate of unwanted energy transfer occurs in the house. So we can see the hottest part of the house, which shouldn't be hot, are colored in dark, and that's going to be the roof. Suggest one way to reduce this unwanted energy transfer. So the best way is to insulate the roof or to install loft insulation. A second house is tested, and it is found that the majority of its unwanted energy transfers occur around doors and windows. Suggest 2 ways to reduce these energy transfers. So you could install double glazing or hang thick curtains to prevent heat from escaping or the transfer of heat energy from the thermal energy store of the house to the thermal energy store of the surrounding through the windows. Or you can reduce the temperature difference between the inside and the outside. Okay, if a house is at 35 degrees inside and it's 10 degrees outside, it's going to transfer more energy to the outside than a house that's heated at 20 degrees Celsius. So here we go. A builder is building an energy efficient house. She has 4 brick brands to choose from for the walls, shown in table 1. Okay, so they have different thermal conductivity and different thickness. Remember, the thermal conductivity indicate pretty much how much energy is transferred through the substance, okay, per surface of the substance in a second. Based on the information in table 1, explain which brick brand you should use. So you should use brick D. Okay, it has a very low thermal conductivity compared to A and B, so less energy is going to transfer through it, and it is thicker than C, so it's going to prevent the loss of heat through the wall a lot more. So D, the lower the rate of energy transfer through the brick, the more energy efficient the house will be. D has the lowest thermal conductivity, so the rate of energy transfer through it will be lower. It is also thicker than C, which reduces the rate of energy transfer through it. Figure 2 shows an old-fashioned well. The handle is turned, which rotates the axle. This causes the rope attached to the bucket to wrap around the axle, raising the bucket from the well. The student measures the time taken to raise a bucket of water from the well. After lubricating the axle of the well, the student repeats the test and finds the time taken is shorter. Explain why. So when you're turning the handle, you're going to do work against friction, and that causes energy to be dissipated. Okay? So you want to reduce the friction, because when you do friction, work is done, energy is transferred. After lubricating the axle, the friction decreased, so less energy is wasted as more energy is transferred usefully to the kinetic energy store of the handle and the bucket. So more of the energy you're transferring to the axle is actually transferred to what you want to do, which is lifting the bucket through the rope. A student investigates which type of window is the best at reducing unwanted energy transfers. The student places different samples of windows on a hot plate and measures how long it takes for the top surface of the window sample to reach 30 degrees Celsius. Okay, so we have the conductivity of glass and air. And figure 3 shows the cross-section of each window sample. Rank them from best to worst for reducing unwanted energy transfers from a house. Explain your choices. So the best one is going to be sample C, okay, because you have some glasses, really thin layer of glass, but you have air in the middle, and air is really bad at transferring heat, and you can see that it is about 8 times better insulated than glass. So C is going to be better than B, even though they have the same thickness. The second best will be B. If you compare B and A, they're made of the same substance, glass, but B is thicker. It will take more time for the heat to be transferred from the bottom to the surface of sample B. So the thicker a sample is, the slower the rate of energy transfer through it. So B is better than A. Air has a lower thermal conductivity than glass, so it transfers energy at a lower rate than glass. So C is a better insulator than B. all these questions, you need to mention the rate of energy transfer, okay? And not just energy and energy wasted. Efficiency. Something that's efficient is going to convert most of the energy provided into useful energy. 20 kilojoules of energy is transferred to a mobile phone battery to fully charge it once it has lost all charge. It transfers 16 kilojoules of useful energy during use until it needs to be recharged. So it could be light or sound, depending on what you do with your phone. Write down the equation that links efficiency, total input energy transfer, and useful output energy transfer. So you calculate the efficiency, you can have useful output energy transfer divided by the total energy input. Sometimes you want to calculate the efficiency in percentage, so you're going to multiply that by 100. Calculate the efficiency of the battery. So the useful output is 16 kilojoules. The total energy input is 20 kilojoules. They're in the same unit, you don't have to convert it. And 16 divided by 20 is 0.8. So the efficiency is 0.8, could also be 80%. An electric motor has a useful power output of 57 watts and an efficiency of 75%. Calculate the total power input for the motor. So the efficiency is 0.75. The useful power output is 57, and we don't know the total power input. So we put our values in this equation. We make total power input the subject of the equation by dividing 57 by 0.75, and we find 76 watts. Again, if you have a question like this, you need your total power input to be larger than the useful output energy. Okay, so if you did find anything below 57, you would have gotten something wrong. Next, students investigate the efficiency of a scale model of an electricity generating wind turbine using the equipment in figure 1, blah, blah, blah. When using 2 cells, the efficiency of the turbine was 13%. Calculate the power generated. Give the answer to 2 significant figures. So we have we have 533 watts of energy supplied, of power supplied. We know the energy transfer is 0.62. So the useful output power of the air blower is 330.46 watts. Then the power generated is going to be 13% of that. And 0.13 times 330.46 is 43 watts to 2 significant figures. So here you have to do 2 calculations. First calculate the useful output power, and then calculate the power generated. You have to use all the values given in the question. Suggest 2 ways the students could increase the efficiency of the turbine. So they could either add more cells or increasing the size of the cells, maybe getting them to have a higher surface area, adding lubricant to the moving part of the turbine, or changing the angle of the cells so they get hit by more wind. So you have to choose 2 of these in order to get the 2 marks. A student is investigating whether the efficiency of a kettle varies with the volume of water in the kettle. The kettle automatically switches off when the water in the kettle reaches its boiling point, which is 100 degrees Celsius. The student carries out the following method. They fill the kettle with 500 milliliter of 20-degree water, calculate the mass of the water, and calculate the energy that should be required to raise the temperature of the water from 20 to 100. That's the useful energy output. Turn on the kettle and allow it to boil and boil the water, and automatically switch off. Measured and record the energy transferred to the kettle whilst it was using a joule meter. Allow the kettle to cool, and then repeat 1 and 4 for different volumes of water. Suggest 1 way the students could improve the experiment. They could measure directly the temperature of the water in the kettle instead of waiting for it to boil and to switch off. At one point during the experiment, the student forgets to allow the kettle to cool before carrying out a measurement for a new volume of water. Explain how this will affect their results. So there can be an inaccurate value of energy transferred to the kettle for this reading because some of the residual energy in the kettle thermal energy store will be transferred to the water and increase its energy. So less energy will need to be transferred by the power supply. Okay? If your water is already hot, less energy will need to be provided to the water to heat it up to 100 degrees Celsius. Then the student record the useful energy output for the kettle for each volume of water and the energy transferred to the kettle. Okay, so for each volume, we have the total energy input and the useful energy output. Before the experiment, the student predicted that the kettle would be more efficient for smaller volumes of water, and the results consistent with the prediction. Explain your answer. So here you're going to have for each volume to calculate the efficiency. Okay, for the first one, the useful energy output is 0.168 and the total energy input is 0.212. So the efficiency is 0.792 or 79.2%. And you're going to do the same thing for all the volumes, and this is all the value you find. And you see that the higher the volume of water, the higher the efficiency, which is against what the prediction of the students. So the results are not consistent with the prediction of the students. The efficiency increases with the volume of water. Okay, the more water you use, the more efficient the kettle is. Energy resources and their uses. I'm going to try to speed up a little bit. So renewable, remember, it's things that never going to run out. They're going to be replaced at the same rate as they're being used up. So biofuel, solar, hydroelectricity, wind, tidal, geothermal, wave power are all renewable. Non-renewable are going to run out. They were produced less fast than they are being used up. So oil, coal, gas, and nuclear fuel, we have a limited supply on the planet, okay, and we won't be able to renew them. Describe the difference between renewable and non-renewable energy resources. A non-renewable energy resource will one day run out, but a renewable energy resource can be replenished as it is used. Most cars run on petrol or diesel, which are both derived from fossil fuels. Name the three fossil fuels. We have coal, oil, and natural gas. Give two other everyday use for fossil fuel: heating up houses or buildings, or generating electricity. Some modern cars are powered by biofuels. What are biofuels? So biofuels are produced from plants or plant products or from animal waste. Okay, and then they're going to be burned like regular fuel to release energy. Suggest one reason why car manufacturers are developing cars that are powered by alternative fuels to petrol and diesel, because we're going to run out of fossil fuels at some point. And also fossil fuels are harming the environment by producing carbon dioxide and sometime acid rain. A UK university is considering ways to reduce their energy bill. They are considering building either a single wind turbine nearby or installing solar panels on top of their buildings. By commenting on the change of seasons throughout the year, suggest why the university may decide to install both wind turbines and solar panels. So solar panels are going to be most useful in the summer when you have long days and a lot of solar energy reaching the surface of the UK. And wind turbines are mostly going to be useful in the winter when it's more windy. Okay, so during winter, fewer hours of daylight, but the weather is usually more windy, so the wind turbines will be able to generate more electricity in the winter. In the summer, there will be more daylight hours, and the weather will be less windy, so solar panels will be more favorable. By installing both, the university will have more reliable electricity supply. An energy provider is looking to replace their old fossil fuel power plant. They're eligible for a government grant, so the initial building costs are negligible. The energy provider is interested in building a power plant that uses renewable energy resources. They have narrowed their choice to either a hydroelectric power plant or a tidal barrage. Compare generating electricity from hydroelectricity and tides, commenting on their reliability and their impact on the environment. So both energy resources are reliable. Tides come in and out at known times. Except in times of drought, there is always water available for a hydroelectric power plant to work. Hydroelectric power plants require the flooding of valleys, which causes loss of habitat. That's not really good. The plants in the valley died during the flood and rot, which causes the release of gases that contribute to global warming. Tidal barrages alter the habitat of nearby animals. Okay, so both of them are good because they're reliable, but they're going to have consequences on the biodiversity and on the habitat of certain species. An alternative is replacing the old power plant with a new power plant that is run on fossil fuels. Discuss the advantages and disadvantages of using fossil fuels to generate electricity. So the advantage of fossil fuels, they're reliable, they're extracted at a fast enough rate that there are always some in stock. The power plants can respond quickly to peaks in demand. It's really easy to turn it on and off. Fossil fuel power plants are less expensive than other power plants. So that's advantages. Disadvantages, they're slowly running out, and also burning fossil fuel releases CO2 in the atmosphere, which contribute to global warming. You can also release sulfur oxide, which causes acid rain that can damage the soil, trees, and habitats. You can also have some oil spillages that kill sea life, birds, and mammals that live near the sea. Okay, that was it. I'm going to post that one for a minute so you can write down all the correct answer. Feel free to go back to write down all the answer you didn't get. Don't forget to stay amazing. Don't forget to revise hard. Good luck with your revision. and I will talk to you again very soon. Bye bye.